Manual in Speedsheet Primer is being brought to you by ACCA. My name is Donald Prather, and I'm Technical Services Manager at ACCA. I can be reached at donald.prather@acca.org or by phone at 703-824-8867. Please don't call me before you listen to the whole thing, though, because I think if you listen to this, you're going to understand how to do manual in Speedsheet, and you're going to be very successful in doing commercial load calculations. First things first, we got rules, and the rules are listed in a checklist, and the checklist is right across from page 1, and it's 2 pages of all the do's and don'ts that are necessary in order to get the proper answers from an NAE. In other words, there's certain defaults set on the speed sheet, and if you're not within the range of those defaults, or you're not within the range of what manual is designed to do, then you're not going to get a right answer, and you don't want to use a manual and speed sheet. You're going to have to go to a full load calculation of some sort. First of all, let's look at walls. There are no below grade walls. Interior finish defaults to none or gypsum board and the following. So that's for all of them. Frame walls have wood or metal studs with siding or brick veneer. Concrete block walls have siding or brick veneer and no exterior finish. Metal walls shall have no exterior finish. Floors and envelope leakage. Floors. The floor may be passive, no radiant heating coils, or may provide radiant heat. There is no basement floor. That's all there is to floors. Pretty simple. Envelope leakage. All spaces shall be at neutral pressure or close to neutral pressure. Spaces shall not be pressurized or at a negative pressure. Infiltration loads shall not be based on a blower door test. That doesn't mean you can't use a blower door test as an idea if you got a real leaky building or something and you need to figure out what range to put it in, but we'll talk about that a little bit more later. Internal gains. Internal gains are produced by people, lights, office equipment, and small unvented appliances. No exhaust hoods, and that means big exhaust hoods, not like a little small kitchen exhaust. Ceiling lighting fixtures are simple troughers, which, what does that mean? That means they're a light fixture. They don't have any ductwork attached to them. They don't have any airflow going through them. They don't have any kind of way that they're adjusting air or air is going in and around them. You see that in commercial buildings sometimes where they have them hooked to the supply or the return ducts. There are no significant motors or motor-driven equipment in the condition space other than the items listed above. Okay, so what kind of motors are listed above? Little stuff like refrigerators and things. But if you have a big motor that's running some kind of a conveyor belt, that's probably not going to fit into this design criteria. There are no animals in the conditioned space. And I'm thinking that he means that you're not keeping a lot of animals in there. It's not a pet parlor or something like that. If somebody has one seeing eye dog, I don't think that disqualifies the building. Internal gains continued. The space has no commercial or industrial production equipment, laboratory equipment, or medical equipment. The space has no open cold food storage cases. Cases with doors are acceptable. The space has no equipment that requires an exhaust hood or an exhaust system. So in other words, other than bathroom exhausts and minor small kitchen exhausts, then, you know, if you have a big hood that's for chemical designs or testing, that's going to be not working for this. There are no hygroscopic materials moving through or stored in the conditioned space. So what does that mean? Hygroscopic materials. Well, they're the ones that absorb water when left in contact with air. Examples include sugar, caramel, honey, glycerol, cellulose fibers such as cotton and paper, ethanol, diesel fuel, sulfuric acid, methamphetamine, many fertilizer chemicals and salts, etc. Does that mean you can't have them in there? It says no, you can have them there, but they better be stored in a sealed package or something so they're not affecting your airflow or they're not in your air that's in your airstream. So if you have a honey bath with a fountain, you know, sorry, you can't use that for a manual NAE. Engineered ventilation. Outdoor air shall be mixed with return air at the return side of the air distribution system or unitary equipment. The neutral system pressure shall be maintained by exhaust dampers at the equipment or relief dampers in the space envelope. The space has no exhaust hoods, no materials capture systems, and no fume capture systems. There is no makeup air. There is no heat recovery equipment for the engineered ventilation. Ancillary loads. There is no space humidification equipment. There is no significant moisture migration through the building envelope. There is no chilled water piping or chilled water pump. There is no steam piping. Structure type. The building may be a residential structure converted to commercial use or a true commercial structure. The height of the building shall be 3 stories or less. No limitation on footprint area. There shall be no basement, below grade walls, or basement floor. There shall be no indoor swimming pool, hot tub, or fountain. There shall be no earth berm walls. Type of HVAC system and HVAC equipment. Cooling is provided by a single zone, constant volume, constant temperature system. There is no chilled water system or steam heat, no pump heat, pipe heat gain, or steam pipe heat loss. There is no makeup air equipment or need for makeup air. The space has no significant exhaust hoods or exhaust fans. Type of HVAC system and HVAC equipment. There is no heat recovery for engineered ventilation, outdoor air for occupants. There is no humidification equipment, no winter or summer humidification load. Design conditions. Cooling equipment operates continuously, constant space temperature, no pull-down load. Applies to any version of manual in. Considering fenestration load and internal load behavior, the peak load unquestionably occurs during midsummer. The cooling load shall be calculated for the occupied condition. Occupants present, lights on. The indoor design condition for the cooling load shall be 75 degrees Fahrenheit dry bulb and 45, 50, or 55% relative humidity. Design conditions continued. Internal gain shall be reasonably constant when space is occupied. No time of day schedules. Cooling load calculations at 9 a.m., noon, 3 p.m., or 6 p.m. are adequate for peak cooling load versus hour of day search. Calculations shall use Table 1A conditions, 99% dry bulb for heating and the 1% dry bulb and coincident wet bulb for cooling. Duct Systems. The duct system shall be installed in one horizontal plane within the building envelope. Duct runs shall be installed in a conditioned space in an attic, dead air ceiling, or floor cavity, or below a slab floor. You can put them pretty much anywhere, can't you? Duct runs shall not be located in more than one type of unconditioned space. Well, you can't run them from 2 or 3 different kind of conditioned spaces and have this software work. Return air shall flow through a duct. No return air sealing plenums. So you got to run through ductwork. That's good design, guys. Duct systems continued. Sealed duct systems default to the 0.12 to 0.24 CFM leakage per square foot of duct surface area scenario. Credit that for a tighter system. Unsealed duct systems default to the 0.35 to 0.70 CFM leakage per square foot duct surface area scenario. And any leakier systems than that are totally unacceptable and shall be sealed. Duct runs in an unconditioned space shall have an R2, R4, R6, and or R8 insulation. In other words, you need to have them insulated. Uninsulated runs are totally unacceptable, and R values of less than R6 are not recommended. Checklist glass. Glass shall not cause a peak cooling load during spring, fall, or winter before 9 a.m. or after 6 p.m. standard time. What does that mean? That means that the glass is supposed to cause a peak load when you're in cooling on your design day or some kind close to that. There shall be no atriums, solariums, or barrel vaults. Applies to all versions of manual in, not just the abridged edition. Roofs and ceilings. For ceiling under a vented attic, the attic is vented to applicable building codes. For commercial roof construction, there is no suspended ceiling, or there is a dead air space between the roof and a suspended ceiling. If there is a dead air cavity, the roof may be flat or sloped. A ceiling cavity shall not be used as a return air plenum. That's a big no-no in this book and in any other design as far as I'm concerned. I've worked on those systems and they're going to cause you heartache. Well, that's the rules, and that's all the rules. And if you can say 100% yes to all of those things, then you're going to get a great load calculation using the manual in Speedsheet. And now we're going to proceed on to the manual in Speedsheet, and we're going to talk about how to use it. Manual NA Speedsheet, peak block load. Sample calculations of a peak block load for the entire space. The calculation is not used to select one big rooftop unit, but to get a feel for the size of the total cooling load. In other words, when you're done, you're going to want to do individual rooms and figure out how much air needs to go to individual rooms. But when you're out on a job and you want to spec something and you want to get the right answer pretty quick, then this does it for you, and it does it in one pretty quick step. Hopefully you already found the Speedsheet. It's available at www.acca.org/Speedsheet, and it's pretty simple to find, or you just can go on our website and look for Speedsheets and you'll eventually get there. When you open up your Speedsheet, which I hope you all can do easily, then you come down to the welcome here. In the welcome, what you're going to do is you're going to read the directions and you're going to see what they are. Well, if you listen to me carefully, you don't have to read all of the welcome directions, but if you have any problems after you start and you want a quick review, you can go back to the welcome. Additionally, they have the help. Now the help lists the order of everything and how it's got to be done. So between the welcome and the help, you should have all the information you really need to do this. It's just in a very short form, like an outline. And we're going to go into a little more detail as we explain things throughout this presentation. Intuitively, you'd think that you would fill in the forms in the order they were along the tab at the bottom. Now I made the tab on the bottom a little bigger on this slide so you could see it. But you end one form in your database, and then you've got all of the little blue ones to the right for the individual loads that you do, like glass and skylights and doors and walls and ceilings, floors, all of them. But basically that's not the way it goes. What you do is you do the database first on all of them, and then you do the blue tabs, and then it automatically scrolls on to the N1 where you may have to fill something in order to complete the job. And we're going to go through this process, but as long as you remember that you always start on the database, then go to the blue, and then go to the N1, you should be good to go. Okay, we're going to start filling out the manual N form now, and the N1 form is the top of the page on the N1 form. You got some stuff to fill out. We're picking the project name, Section 12 NAE, because I'm basing my form on the Section 12's block load done in Athens, Ohio. And we've got square footage of 3834 and 9-foot ceiling, so 9 times 3834 comes out to 34506, and it's just that simple. We're putting in the above grade AG volume, square foot, and the project name. All right. Well, now we move on to the next step. We got some scroll downs on there that we got to fill in, and we're going to scroll down and pick the design state Ohio. Then it gives us a list of cities, and we scroll down and we're going to pick Athens, and then we're going to scroll down and pick the type of load, and we've got block, room, or zone load. So we're going to do a block load because we're figuring out for the whole building so we can know what size equipment we need to put in there, and we can kind of estimate the ductwork then based on the CFMs. And we can make a reasonable bid, and so we don't need to do each of the rooms. Now if we're doing each of the rooms or each of the zones, we could then use type of load as zone or room, and we could really break this down further using the manual N, and we'd end up with several pages, and we'd have one for each room. Now the really cool thing about the Speedsheet, if you're used to doing these things by hand, then you're used to filling out a lot of paperwork and writing the same numbers over and over again. Well, the Speedsheet doesn't make you just write the same numbers over and over again. It automatically populates them. Now, when you see the blue lines here on this paper, then that's going to generally mean it's automatically populated. And you can see some of the stuff that's automatically populated, like the design temperatures and the latitude and all those kind of things that, once you pick your city and your Ohio and Athens, should automatically populate. You shouldn't have to write them all in again. And that's what this sheet does for you. We want to pick all these numbers out of the manual N, and that's important to remember. Is you need the manual N in order to find out what the construction codes, descriptions, and frame constructions, and the U and the SHGC values all are, and they're in the manual, and you pick the ones that are closest to what you actually have in the field or match it as closely as possible. Database. So now we click on that red database button, and we're going to start filling things in using our manual. We got window type and value, and we got no direction in here yet, but we got 1A, CUO, is the last bottom one there, and single pane 1/4 inch glass, and it's operable, and there's no metal break. Next we need the window Uvalues and the solar heat gain coefficient, and those values, you can see the Uvalues and the solar heat gain coefficients both increase as the type of window gets cheaper. So if you have a really expensive triple pane window with a film on it, it's going to have a very low U and solar heat gain coefficient. And if you have a really single pane one, you're going to have something like what you got down at the bottom. So you need to figure out what type you have, and then you can pick the solar heat gains and U factors at closest matches that are from the glass data tables. We're now ready for step 2 in our 3-step process. We go to the glass 1 tab down at the bottom and hit it. The next step after that is we click on the little scroll down and we select one of the glass windows that we entered earlier, and it'll automatically pop up at the bottom of the page in the blue column on the left. The next step is to fill in our quantity, our direction, and the width and the height for each of the windows and for each of the window types we have. If you look at the bottom of the page, we also have to do the overhang distance and the top of the opening to the overhang. There used to be a width on here and of the window, but that's been removed because the math automatically does that when it goes to the next page. Additionally, On the right hand side of that, we need to fill in internal shading, glass adjustment, and construction weight. The choice are internal shading or none, or blinds at 45, and for glass adjustment the choices are none, insect screen, bay window, garden window. Construction weight is light, medium, heavy, internal shade. We've now completed filling out the Glass 1 tab, so we press the Form N1 tab at the bottom of the page and we go back to the front page of the form. Once we're back on the first page of the form, we're going to concentrate on the glass section of the sheet. What we're showing you here is a close-up of the window section. And you click on the lookup, and then A through H gets entered based on clicking on it, and you just select it, and it fills in all the stuff over here that the blue arrows are pointing out. And in the end, you only have to fill in your net area or length. In this case, it's net area, and that's 48 for the first one up there on the top. And then that gets multiplied times the cooling HTM or the heating HTM to give you your heating BTUs per hour or your cooling sensible BTUs per hour. And all this is done automatically by the Speedsheet for you, so you get all the totals done. Once all the window sections are filled in, and you can see them here, they're A, B, C, D, E, F, G, and H, and that's all the more room you have on here, then that's the end. You're done with the windows, and the windows are complete. The skylights, you follow the exact same pattern. You do the exact same thing. Let's give a quick review now on how to do the skylights, since I mentioned that. First, you're going to look at the skylights, then you're going to look at the database, and you're going to fill that in for the skylights. Then you're going to go to Skylight 1 and fill all that information in, and then it'll get up on the manual N1 form when you bring it up. So it's just the same order, same procedure, and you do it for skylights. We follow the absolute same procedure for doors, and so I've already gone to the data table here, and this is a close-up of the data table, and we're going to put in 11J for the construction number, and we're going to put in the type of door that's in there, metal fiberglass core, and we're going to have a U value, and for that door it's 0.60. And so now we're ready to move on to the next sheet. Next, we move to the Door 1 tab. There we'll select the door A or B type and using a scroll down, and then we'll enter the direction, and with the net square feet and the color. After that, we push on the button on the bottom there that returns us to N1 form, and we're ready to finish the N1 form for doors. Once back on the N1 form, we do the lookup and we find the door that we want, and we click on it, and it comes out the direction that we want it to face, and then we put in the square footage, and the rest is automatic. The multiplication is done for us, and that's the end of the doors. We're all done with doors. Now we go to the database again, and this time we look for our wall section in there, and we go to our manual in and we look up our construction numbers that match what the building is, and we enter those in. We then enter the descriptions that match the construction numbers, the U values, and the group value, all from the manual in text. Once again, we hit the Wall 1 tab, and we're back at the Wall 1 tab, and we've got A through H here for the wall types that we can select, and we click on the scroll downs and scroll down one wall type that we want for each section, and then we fill in the net square feet for that wall, the direction the wall's facing, the color of the wall's facing, and once again at the bottom of the page we jump in there and return to N1 form to finish the job. Once back on the N1 form, we click on the data and we fill it in, and then we move on to the next one. Next, following the order of the form, we use the database tab for ceiling data, which is the next one further down. And we see once again we have a construction number and a description and a U value and a group number to fill in. After we do that, we can go to the next one and click on the little scroll down. You can see it here highlighted, and we select one of the types that we have. We put in the square feet and the color, and boom, we're back on the N1 form. We click on the bottom on the N1, and we click on the data for the door, and everything fills in for us, and we're good to go. Since my problem's from chapter 12 and the manual in, and that chapter has a block load, and that block load is over a conditioned space, I don't have any floor data to do. If I did, I'd go database, the floor 1 tab, to N1 form, and I'd fill it all in. But since there's controlled space below it, there's no heat loss through the floor, and so that would be the end of the database stuff. If you had a floor to fill in, you'd fill that in. That'd still be the end of the database form on the Speedsheet. So you use the database up until now, and then all of a sudden we go to a 2-step instead of a 3-step method to fill in the sheet. Next, we jump into the two-step. Well, how do we do that? We skip the database down here in the bottom. We don't click on that tab anymore. We go straight to the internal one tab. And then we're going to fill in the diversity factor, which is DF on this sheet for lighting fixtures, and the diversity factor for occupants. And we're going to fill in the number of occupants and the number of lighting fixtures. And we're going to fill in the office equipment and its diversity factor, and the food service equipment and its diversity factor, investigated loads and plants and blower heat. And we're going to fill all that in on this sheet, and then that's going to give us our internal loads. Once we're back on the N1 form, we're going to start entering the internal loads: lighting fixtures, occupants and plants, office equipment, food service equipment, and blower and heating equipment. And then once we're done with all of those, we click on them and we select where they go. They fill in automatically over here, and we're done with that. We move on to the next step. What we have here next is the Infiltration 1 tab. Now we're getting near the end. You hit that blue tab down the bottom and you can figure out levels of exposure and tightness for the doors. And then what you figure out is how often you have the doors opening and closing, what the door traffic is, and that's what the operating cycles of door per hour is, what TR is. And then it figures out that the description of the door is, and you've put all that in here. And then this will go in back over into the N1 form, and we click on N1 down at the bottom here when we're finished filling out all this information, and we're back here. And then we'll do the lookup. We'll do that. It'll have the infiltration, the supply duct load, the return duct load, the ventilation loads, and the blower equipment heat load, and all that stuff will come in here automatically and fill in. Finally, we're getting to the last step. We hit the Ventilation 1 tab, which is the furthest one over on the sheet, and then we fill in our code required CFM, or our occupants and how many CFM per occupant, or a value that we selected on air changes per hour. And any way we do it, it's going to automatically get the right answer for the BTUs on the final sheet when we go back to our N1 for the last time. Well, if you followed me all the way to here, then you got it 100%, because this is it. Once we're down with the ventilation loads, then we fill them in on the N1 sheet and we get our total loads. You can see them down there on the bottom. And what you have then is you have a complete sheet on the N1 that you can print out, and you have a load calculation that you can turn in. So in the end, the whole sheet looks like this. It's all filled out. It's nice and neat. It looks printable. You got your totals down in the bottom right-hand corner. You can now use this sheet to size your equipment, and then you can select the equipment and install equipment that you can have confidence will work properly in your commercial building. One last thing before I conclude this all is, once you get one of these sheets filled out, save it, because you have a sheet that you can use. If you have the same type of building materials, it's already all filled in. You just have to change the direction and the address and some of the sizes, and you've got a template. So the more of these you do, the more templates you have, and the quicker it is to do them. If you got any questions, give me a call, and if you have any suggestions on how to make this a better tape or ways I can explain this better, then for sure give me a call, because I'm always trying to get a little bit better at explaining this stuff. Have a great year. Bye-bye.